Hi guys, it's me again, Angie, and welcome to another video. For today's video, I'm going to show you, or I'm going to do the inside activities in chapter 5. So I will open my NetAcad, then the course index, then we will find here the activities. So the first activity here is the Mac and LLC sublayers in 5.1.1.5. Then we will try to answer the questions here. So the first is controls the network interface card through software di- drivers. So my answer is LLC. Then works with the upper layers to add application information for delivery of data to higher level protocols. So my answer here again is LLC. And then works with hardware to support bandwidth requirements and checks errors in the bits sent and received. So my answer here is Mac. Controls access to the media through signaling and physical media standards requirements. My answer here is Mac again. And then supports Ethernet technology by using CSMA or CDR, CSMA or CA. My answer here is Mac again. And then remains relatively independent of physical equipment. And we are going to check it. So as you can see, my answers are all correct. Then the next activity is the 5.1.1.6. That. So as you can see, there are choices here. I'm going to drag it here to find the correct answer. Uses pad to increase this frame field to at least 64 bytes. So my answer here is this one. 802.2 header and data. Then describes which higher layer protocol has been used. So my answer here is this type. The frames originating NIC are interface MAC. So my answer here is source address. Assist a host in determining if the frame received is addressed to it. So my answer here is destination address. Notifies destinations to get ready for a new frame. So my answer here is preamble. Then synchronizes sending and receiving devices for frame delivery. So my answer here is start a frame delimiter. Then the last question is detects errors in an Ethernet frame. My answer here is this one. So we will check it. Then as you can see, all the answers are correct. And then the next activity is this. No. Course index again. Five point 2.2.4. Descriptions of switch frame forwarding methods are provided in the table. Click in the store and forward or cut through fields to match the methods to the descriptions. Buffers frames until the full frame has been received by the switch. So my answer here is store and forward. Checks the frame for errors before releasing it out of its switch ports. If the full frame was not received, the switch discards it. My answer here is store and forward again. Then no error checking on frames is performed by the switch before releasing the frame out of its port. So my answer here is cut through. Then a great method to use to conserve bandwidth on your network. So my answer here is store and forward. The destination network interface card or the NIC discards any incomplete frames using this frame forwarding method. So my answer here is cut through. The faster switching method but may produce more errors in data integrity, therefore more bandwidth may be consumed. My answer here again is cut through. Then we're going to check. Then as you can see, all my answers are correct. For the next activity, the instruction is read the scenario based on the topology shown. Identify how the frames will be processed by dragging your answers to the appropriate fields provided in the table. All answers will not be used. So there are choices here. We are going to drag it again here to answer the questions. Cabling used in this topology will be, my answer is straight through. To find where PC2 is located, PC1 will send out a broadcast data frame. So we will find broadcast. PC2 will respond back to PC1 by sending back a unicast message. So I will drag it here. If PC2 receives only half of the data in the frame, it will discard it. The half of the data in the frame will discard it. If PC2 receives many damaged frames on port 3, S1 likely will change back to store and forward switching. Then we are going to check if my answer is correct. As you can see, all my answers are correct. And then I'm going to go back to 5.1.1.6 because there is another activity. Drag the Ethernet frame field name to its correct location on the diagram. For 7 bytes, preamble, I'm going to answer it. Start of frame, the lemur. And then destination address. And then source address for 6 bytes. And then length for the 2 bytes. And then 802.2 header and data for 46 to 1000 bytes. And then for the last one, 4 bytes, frame check sequence. So let's check if my answers are correct. So as you can see, all my answers are correct. And for the last activity of this chapter, 5.2.1.6, the switch it challenge. Oh my god. So let's try this. So correct in question 1. The parts that you selected is not correct. So I will try another one. FA3, FA5, FA7, and then switch. When the switch forwards the frame, which statements are true? In question 1, the parts that you selected is not correct. So let's try again another one. In question 2, your answer for how the switch will handle the source MAC address is not correct. So